Hello grade 6s, welcome to your mathematics lesson today. I'm Carmen and I'm so excited to be taking you through recognizing the place value of digits. Oh my goodness, doesn't that just sound like it's so confusing, the place value of digits? But don't worry, we got this, we're gonna get through it, and you guys are gonna be experts by the time this lesson is done. So let's get started. Okay, so if we look at the numbers over here, we can see that there's lots of different ways that numbers can be represented. So we've got our number, which is 243. And then we can represent it in terms of blocks. So blocks, simply put, are little blocks, exactly like that. So our number is 243. So here we've got 100 and 100. So each block stands for 100, and that is representative of the 200. Then we've got 4 little blocks over here, which obviously represent tens. Okay, so in representing that, we know that it means because there's 4, because of the number 4, it's 40. 4 times 10 is 40. Okay, then we've got 3 over here, which is our units. So this is our units, and it is 3 blocks. Okay. Next, we're looking at numerals. So numerals are our most recognizable form of numbers. We see numerals everywhere that we look. We see it on cell phones, we see it on TV, we see it in books, we see it when we're practicing. Numerals are generally how our numbers are represented and how we see it most. Okay? So simply put, it's 243. And the way that we say the numbers like 243, those are representative of what the place value of these different digits are and why the numbers are 243 versus something else. Okay? Now we're looking at expanded form. So what is the meaning of expanded? Expanded means simply to continue or to go or to prolong. So it means that it is expanded or it's made bigger. Okay, so it means that we are now writing out each of the different digits in terms of the numbers, in terms of the value that they represent. So if you can see here with our 200, we've actually written out the whole 200 plus 40 plus 3, okay? Plus 40 plus 3. So we've written it out in expanded form. Okay, now let's take a look at numerals and words. Sure, as if expanded form isn't hard enough, we also have numbers that can be written as numerals and words. So over here, usually the number that's present first will just be the digit, which is the 2, will just be the 4, which will just be the 3. And then the expanded form is basically the place that it represents. So because the 3 is represented by units, we fill that out. Because the 4 is represented by tens, we fill that out. And because the 2 is represented by hundreds, we fill that out. And that is our expanded form. The 200, 4 tens, 3 units. Okay. Now our words, okay, so our words mean that we actually physically write out the word representation of our different digits. So we've got 2, so instead of just writing a normal 2, we are writing out the word. So 243. So when you can see here, in terms of your words and how you write out your numbers, your 43 is combined because it's combining your tens and your units together in terms of that expanded form. And we put it together with this over here so that we can show that it's one number. Okay. Then you've got your Roman numerals. Okay. So your Roman numerals, this represents your 100. So those 2, this represents a 40, and this represents your 3. Okay, so this section or this slide took us over how we can represent numbers in different in different forms. So now we're going to move on to actually exploring the place value of digits. Okay, so I like to always look at it from this side, from the small side, which is the units, to the big side, which is our 10 millions. So we start off with a unit. The unit is represented by 8. Then we've got tens. Okay, then we've got hundreds. Then we've got thousands. Then we've got this over here is 10, and this is the thousand, so 10 thousands. 100, so 100 thousands. Then we've got millions. Wouldn't we all love to have millions and millions? Then this one is 10 millions. So you see, each of these numbers represent a place on this little continuum, which gives us how we actually recognize numbers, right? So if we can see over here, we've got 94,562,138. Isn't that a massive number? Okay, so what we're going to be doing is we've learned that we can represent numbers in all kinds of ways, in expanded form, in blocks, in numerals, in words, in numerals and words. So now we're just going to practice how we actually write these numbers out in numerals. So our first one over here is 5,452,680. Okay, so how are we going to write that number down? So we've looked at our place value, and we now just need to remember that we have 5 million, and then we've got 452,000. Okay, so we've got 452,000, but we've also got 688. So we have 688. Have you got that, guys? Awesome. Okay, so here we've got 74,673. Okay, so here we've got 74,673. Can you see that, guys? Does it make sense? So if we just go back to our previous slide, we can see that we are placing the numbers underneath where they fall within this continuum. Okay, so now we've got 92,862,140. Oh my goodness. Okay, so let's start off with our big number over here, which is 92 million. Okay, but we've also got 862,000. Okay, so we've got 862,000. Okay, and then we've got 140. So 140. So there's our number written in numeral form. 92,862,140. Okay. Awesome, guys. Sure. So that was a little bit tough. Now we need to write these numbers out in words. So remember, we need to remember where all these numbers fall so that we can write them down. So let's read this number out over here. We've got 450,096. Okay, so we've got over here 400 and 50,000 96. Okay, awesome, guys. Now let's look at 875,106 and 106,006. So this one is a little bit tough because it's got millions in. So we've got 875 million 106,006. Okay, and then our last number, 43,796. So let's try and write it out. 43,796. Sure. Awesome, guys. Okay, so now that we've got that down, we've learned how to take words and write them into numbers in numerals, and now we've taken numerals and we've written them out in words. Okay, so now what we quickly have to do is we need to state these values in terms of where they form on the actual continuum. Okay, so if we look over here, this one that's underlined. So let's start with this example. Here we've got 4,574,145. So we can see that the 4 is underlined and it's thousands. Okay, so we've got here, well, this is underlined, so 14,741. So we know that that is hundreds. Okay, here we've got 78,498. Okay, but remember, it's not just this thousand because it's tens of thousands, so it is 10,000s. Okay, this one over here is 102,147,832. So our 2 over here is a unit. Okay, this one we've got 78,658,489. So we know that that is our 10 million. Okay, this one that's underlined is our 2. 100,120,478. Our 2 is underlined, and we know that our 2 is 10,000s. Okay, and the last one over here, 47,551,014. Okay, and here we can see that our thousands is the one that we are looking at. Okay, so our last one over here, now we need to build these numbers given these descriptions below. So a number with 1,000, 3 tens, 5 millions, 6 10,000s, and 200s. So we just need to write them. You guys can write them out in terms of where they fall along the continuum. So like that. Okay, and I will just fill them in over here. So 5 million, 6, 1, 2, and 30. This one over here, which is 7 10,000s, 8 units, 200, 6 millions, and 5 tens. We've got 6 million and 70, 258. And our last one over here, which is 5 million and 19 and 050. Well, guys, that's all that we have time for today. Thank you so much for joining me in terms of helping to figure out the place value of digits. I hope that you guys keep practicing. It is a little bit tough, but I know that you'll get it. Just keep on going, and I look forward to seeing you guys next time. Take care of yourselves. Be safe. I'm out. Goodbye.